Thank you. Now, having understood what is DC load line, now we have to know what is AC load line. So AC load line means, as usual, as I said, you have to consider the load resistance also. Because you are using coupling capacitor to couple the output from the output of transistor to the load, right? So at the output side, you have to consider the effect of RL also in your AC load line. Remember, in DC load line, no RL. Only in AC load line, this RL will come into picture. Because I'm using a coupling capacitor to couple the output from the collector to the load of my external circuit. Okay. So at the for the AC load line, after drawing the DC load line, definitely you have to fix your Q point and you have to draw the AC load line also. So only when you draw the AC load line, you'll get a clear understanding whether your transistor is fit to be working as an amplifier or not. So for drawing the AC load line, first you have to find the output resistance in the output side. You have to find the effective resistance in the output side. See, in the output side, you see, for finding the resistance, what you do, you have to short circuit the voltage source. So what voltage source I have? I have this voltage source VCC. Okay, so I'm going to short circuit that. Okay, I'm going to short circuit that. So I'm going to ground it. Okay, and see, RC is between collector and ground. RL is also between collector and ground. So how are RL and RC related? They are series or parallel? I am finding the output resistance in the collector. For that, I need to short circuit my DC source. So you see the RC is present between collector and ground. RL is also present between collector and ground. So can you relate RC and RL? How are they related? They are series or parallel? Yes, they are parallel. See here. So RAC will be the effective load resistance. RAC will be parallel combination of RC and RL. See, it may look, the diagram may look like series. You can see the same current, you can say entering is flowing through RL. No, here you see the current is splitting, right? So here the current is splitting. So definitely the current coming through RC is not the same current flowing through RL. So RC and RL are in parallel. So I'm going to call that as the AC resistance RAC. So RAC equal to RC parallel to RL. That is the only change. That is the only difference. Instead of using RC in the diagram, see here, in this equation, instead of using RC, what we'll be using? We'll be using RAC. That is the only change. And same way we find the two endpoints as we did for DC load line, and we get the two endpoints C and D. So see here, same way to draw the AC load in also, we have to find the two endpoints, because for drawing a line I need two endpoints. How to get that? One, you put VC equal to 0, and one thing you put IC equal to 0. So when you put these two conditions, you get the two ends of the AC load line, and that is got from this